Still on enzymes here, we can talk about naming them. Now, we're not going to have to name them specifically, but just understand where they come from. Over here, you can see I have, well, it's supposed to be fully, that's phenylalanine, and it's reacting with this compound. So what we do here is the way that we name them, the first part identifies the substrate on which the enzymes act. So in this case, this enzyme is acting upon phenylalanine, so it's phenylalanine. Second part identifies the class of the reaction catalyzed. Um, so here we go. You have these are some examples: succinate dehydrogenase, or pyruvate decarboxylase, or lactate dehydrogenase. Here we have phenylalanine, and we get a transfer of an NH3 group. So this is phenylalanine transaminase. What those do is they move amine groups. So there we go. There's our enzyme. How they work, a lot of them work with lock and key model, or lock and key mode. The substrate connects the enzyme after the reaction. After a reaction, the products cannot stick to the enzyme, so they are released. All right, so the reaction happens and they can't stick to the enzyme anymore, so they go away. Lock and key model versus the induced fit. The lock and key model, the shape of the active site is rigid like a lock, and so the enzyme has to be like a key that fits perfectly in there. The induced fit, the shape of the active site is flexible, and so things can like move around so that they can then react. These are just two different modes of operation. There's a whole bunch of stuff that relates to how quickly an enzyme will catalyze a reaction. Here, temperature is important, like the rate ramps up really fast and then drops down really fast. So they work in a very tight temperature window. They also work in a very tight pH window. Um, because they do very, very specific things in very, very specific areas of the body. There's something called allosteric control. This is where the regulator binds to an enzyme that affects its ability or affects the ability of the enzyme to bind to the substrate. So something else comes in and attaches itself to the enzyme. So the enzyme either has negative allosteric control, which means it makes it so the enzyme can't bind to the substrate, or it has positive allosteric control, which means once this thing slaps itself onto the enzyme, that enzyme can stick to the substrate more strongly. And because of that, we have different ways of controlling the rate of reaction. When we talk about inhibitors, this is exactly what you think. It inhibits substrates that bind to enzymes that totally change or destroy the enzyme activity, so they slow them way down. There are some reversible ones and then irreversible ones. There's some that are non-competitive. You can see that there's a whole bunch of stuff going on here. All right. This is just vocab. You guys are going to be able to read through that really easily. Essentially, this comes up with penicillin. When you have penicillin, it deactivates the bacterial enzyme. So the bacteria can't do certain things, therefore it dies. Sulfanilamide, there it is, sulfanilamide, does not allow bacteria to make folic acid, and folic acid is an extremely important compound for any biological system. And lastly, we have enzymes and diagnosis treatment. You can read these like creatine, phosphokinase. This means usually when you have elevated levels of this, it indicates a heart attack. Alkaline phosphatase, liver or bone disease. You could start seeing all of these. And by identifying some of these enzymes and their concentrations in the blood, we can then identify diseases sooner, which is very, very important. There's something called an ACE inhibitor. This is a treatment for high blood pressure. And what the ACE enzyme does is it comes in and it clips these two amino acids off here. So it comes in, snips those off. And what this compound does is it constricts the blood vessels, which will elevate your blood pressure. What an ACE inhibitor does is it takes this ACE enzyme and inhibits it from doing its job. And by doing so, your blood vessels won't constrict and you can lower blood pressure. So that's one way to treat blood pressure. So there. And then now this is for HIV protease inhibitors. These are enzymes or inhibits enzymes that allow the virus to make copies of itself. Very powerful drugs here. But first of all, I know very little about HIV, so please don't ask me any specific questions. My understanding is that someone with HIV is going to be their treatment is going to be very individualized. And so they're going to get a drug cocktail that's specific to their needs.